Alright, so here we are, lesson 225, a little bit more on buck boost transformers, calculation and selection. So last time we really talked about amperage and volt amps. This time we're going to focus mostly on voltage. I would argue this lesson probably should have been before 224, but nonetheless, they're all going to kind of go together here. So first thing we got to get out of the way is we need to take a look at the Year 2 textbook Annex D. So the back of your textbook, you're going to find Annex D. It's going to contain various information on transformers that these problems are going to refer to. So you see here, first of all, we have different groups of transformers. We have Group 1, Group 2, and Group 3. And the biggest thing we're going to find is right here at the top, one of the most useful pieces. So like this Group 3 transformer has a primary. Each one of these primary and secondary has two coils. So it's going to have a 240 by 480, meaning two 240 coils, and then it's going to have a secondary 24 by 48 or two 24 volt coils, right? So that's going to be different for each group of transformers, so we're going to need to refer to that. You're also going to see a bunch of other info that could be useful for the problems we're going to do. We don't necessarily need most of this info, but this is where you would go to find that kind of stuff. And then lastly, in Annex D, they give us a set of wiring diagrams, in this case C through J. But we're going to have to refer to various pieces of this as you do your homework equations. So I really just pulled out two different equations, one for buck, one for boost, and we're going to run through them. And again, I think that's kind of as detailed as it needs to get here. I'm going to really strip it down and I think make it as simple as possible. The book has a lot of information in there, but I think this is a really nice method to sort of calculate these things. So here's a question right out of the homework again. So they're going to tell us here basically, we have a 2-pole breaker and a 122.8 volt panel. We have equipment that's rated for 220. The supply circuit voltage is 206 volts. Not 208, but 206. Seems awfully specific, but anyway. Where it enters the BV transformer. If connection diagram H from Year 2 Annex D is used in Group 2 transformer, the equipment will be supplied with X volts. A lot of information. So the first thing is what information is relevant here. First thing is we know the equipment needs to operate at 220 volts. So that's what we want to get out of our transformer or close to it. Next up is we're feeding this whole system with 206 volts. Lastly, we're going to use a diagram H, connection diagram, and it's going to be a Group 2 transformer. Okay, so that's really the only relevant info that we need to answer this question. So let's jump over to check that Annex D again. Let's see what the Group 2 transformer says here. If you notice, we are 122/40 primary, 16/32 secondary. And then last thing, let's check what does diagram H look like, and this is what we have here, right? So let's drop back and just put that info on our sheet here. So basically we're going to have our input connected here and here. That's going to be 206 volts, right? Output, we don't know what it's going to be. We need to calculate that, but we're hoping it's around 220, right? So the way I like to kind of calculate this is assume that the rated voltage is meaning it's one wrap for every volt. So we know this is a 120 volt coil, that's a 120 volt coil. So we have 120 times 2, which is where we get our 240. Same thing, we know that's a 16 volt rated coil, 16 volt rated coil, that's where we get our 32. So assume that each rated volt is kind of one wrap around, right? So if we apply 206 volts to these 240 wraps or turns right here that it's connected to, we would theoretically have 0.858 volts per turn, okay, or 0.858 volts for every 240, right, however you want to look at that in this case. So essentially for every one rated voltage, we're actually only getting it out 0.858 in this particular case with our input voltage. So we know already that we applied 208 volts here. So the output now is connected here, but then we add this extra little bit of these 216 volt coils. So our output's here and here. So we really need to calculate the voltage on these two coils now. So we can kind of use the same logic and say we have 16 and 16, that's 32 turns total. We already said 0.858 turns, or 0.858 volts per turn. Same as we just figured here, so we can simply multiply that through. 32 by 0.858 gives us 27.456. So now this section, this 32 volt coil or these two 16 volt coils will impose 27.456 volts into our circuit. So now this output goes across these two coils plus these two coils. We've already determined it's 206 input here plus the additional 27.456 there. We add those together, that gives us our total voltage across all four coils. So our final answer should be 233.456. And you're going to find that on almost all these buck boost questions. We wanted 220. We're not going to get exactly 220. We always get somewhere pretty close. But that right there is kind of the whole ball game, how you would figure out, in this case, a buck question. So we're raising the voltage. So next one, let's look at another question straight from the homework again, where I'm sorry, that last one was a boost. Now this one's going to be a buck. We need to lower the voltage. So in this case, we have a panel. It's 120 by 240, 4-wire control panel, requires 208. Fairly common, I guess. Not hard to imagine. 3 kVA buck boost group 1 transformer from gear 2 NXT. Calculated voltage that will be applied to the control panel is blank volts. Assume proper connections are made and the input voltage is exactly 240. Once again, what's the relevant information? They gave us a lot of info that we don't need to know. So it's a 240 volt panel, and they tell us assume it's exactly 240. So we're going to have a 240 volt input. We want to get 208 or close to it on the output. Or they're telling us we're going to use a group 1 transformer. What's missing here is they're not telling us the connection diagram. Okay? We can find that out, not a big deal. So let's go over to the Annex D, look at the Group 1 section. First thing to notice, it's 120, 240, and 1224. A little bit different from the last one that was 1632. Now we're 1224. So the next question, though, which connection diagram do we use? And if you look here at the top, we haven't looked at this yet. If we're boosting or bucking our voltage, we can pick what our available line voltage is, and it'll tell us all kind of different stuff about various transformers. In this case, we want to get 240, so we can't choose that as an input. We got to go 230, 245. I would suggest go with the 245. It's closest to 240. Regardless, now if we drop all the way down, we would see that it's an I connection diagram. Even if we pick that 230, it would still be an I connection diagram. So let's check out the I connection diagram. Looks like this. So we're going to have our input here and here, and our output is only across these two coils. Kind of the opposite of what we did last time, right? So, once again, we're going to have 240 in to the input, and then our output, we want to get close to 208, so we're hoping to see something in that range. So, first of all, how many total wraps do we have across all this? Because now we got to look at our input voltage. It's going across every single coil. So we got a 120, a 120, a 12, and a 12, or a 240 and a 24, however you want to look at that. Regardless, we get 264 total turns across all of this. We apply 240 volts to all those turns. 240 divided by 264 gives us now 0.909 volts per turn. So for every turn, we should get 0.909 volts out. Or for every 240 volts in, or for every 1 volt in, we're only going to get 0.909 volts out. Right? So next thing we do is our output is only connected across this coil and that coil, 120 and 120 for a total of 240. So we take 240 turns times 0.909 volts that we calculated in the last step. We get 218.16 for our output. So there again, I think that seems simple, and I hope you guys find that it is too. Again, the book really drags that out into a lot of steps and a lot of math. I think this is a simple way to think about it. It's pretty tried and true. So keep this method in mind as you're working through some of those example problems.